Well, hey there, HVAC pros and enthusiasts. Are you ready to take your skills to the next level? The HVACR Learning Network has just launched an exciting new e-learning course, High Performance Heat Pumps. And guess what? We're giving you free access to the first 2 chapters. Whether you're in the field, training for that next step, or simply want to sharpen your expertise, this course is packed with everything you need to understand and master high-performance heat pump systems, especially inverter-driven cold climate heat pumps. And the best part? You can access it anytime, anywhere, right from your favorite mobile device. It's HVACR learning made flexible and convenient for you. So what are you waiting for? Click the link. Dive into the HVACR Learning Network and start your free trial today. Your journey to HVACR mastery begins here.
Well, hello everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. You know, even just by that intro, we spend a lot of time talking about innovations and technologies that are coming to the industry. And sometimes we'll talk about, cold climate heat pumps as like it's a new technology. But when we really start looking at the industry, there's a technology that has been around that is really the heat pump that works in cold climate, no matter how cold it is, if you know how to install them properly. So today we're spending some time with Jay Hammond from WaterFurnace. How are you doing today?
Great, Cliff. How are you?
I'm doing wonderful. And what I mean by that is when we start talking about geothermal systems, geothermal has the ability to function in any cold climate when they're installed properly and they're operated properly. They've been around for a long time. And unfortunately, a lot of people don't understand geothermal systems very well. And I think we're going to start seeing a lot more of those going forward. And I think it's important that we start working with our manufacturers and our training organizations to make sure that we've got those resources, especially for educators and contractors that are wanting to stay up to date. They are connected with all of the right resources. And WaterFurnace is the top of the game in the geothermal. So, Jake, tell me a little bit about your history in the industry, because I think it's very important when we start talking about technologies, because you and I have been in quite a few of the same arenas, and we both enjoy this educational side of it.
Oh, absolutely. I started doing geothermal back, right out of high school. So it's been 30, I'm really that old, probably 35 years or so. Did, just basic service work and some install, put sheet metal together and all the fun stuff. And got an opportunity to work as a tech service advisor for WaterFurnace back in the early 90s. So started out doing that. Got me into a sales position and then just a couple different positions around, different manufacturers. And it kind of always, it's kind of funny because even in a sales position, it always kind of went back to training. So
Yep.
it's always been a training thing. And geothermal is one of those industries within HVAC that kind of, once it gets you, it kind of keeps you there. I tried to get out of it for about a year and it sucked me right back in. So it's just a lot of fun.
We talked about our experiences with rack refrigeration as well. And I always feel like the refrigeration, even though it is, it's the same industry, a lot of people look at it as a separate industry, and it's kind of like geothermal, right? It's the same industry, but people always look at it as like a separate component, and it's not.
Right.
We're all doing the same things. We're all in the business of moving heat. That's really what it
Exactly.
comes down to, right? Kendrick, thanks for
Exactly.
joining us today. Yeah, so we're going to spend some time diving into geothermal today. And so if you have some questions along the way, just let us know. We'll see if we can answer them. And we're going to connect you with the resources for getting all the proper training, because that was one of the things that impressed me about WaterFurnace is, the heart of what the technical team is training.
Yeah.
And you got 5 full-timers on the staff doing training. Is that correct?
That's correct. We got 4 full-time trainers and myself.
Mm-hmm.
And I try to stay out of the office and do as much training as I can.
Yeah. I'm the same way. It's important for us to stay in the field. That's why we do so much of these shows. Many of us as educators, we came out of the field, right? We were technicians that made our way into education. And so if we don't stay out in the field, or at least stay connected with people that are in the field, it's easy for technology to surpass us and us not be comfortable to teach about it. And there's a lot of things going on in geothermal that people need to be aware of, for sure.
Oh, absolutely. Absolutely.
And you're located out of Fort Wayne, Indiana.
That's correct. We're in Fort Wayne, Indiana. U.S. made product, so that's a good thing for us. We've been here for quite a while. We actually built our first building. Well, actually, we've been around before that. But we built our first building where it is currently in 1991. So we've been here for a little
Nice.
while, 35 plus years.
Yeah, I know I've heard the name a lot out in the industry. It just wasn't a field that I encountered very often, and I wish I would have spent more time. So this will be good education for me as well.
Absolutely. Well, one of the things that we really pride ourselves on is we have a lot of employees that have 35 plus years with the company.
Oh wow.
We started back in 1983. So, as a matter of fact, one of my trainers, Tom Kinder, which some people listening may know Tom. Tom's a great guy. He's been with Water Furnace. I believe he's on his 38th year right now.
Wow.
So, just, a really long time with the company and kind of been there and done that with most of them. So, Tom's a great resource for us. We have two product lines. We have the Water Furnace product line that we sell to our dealer direct customers, and
Mhm.
we have our GeoStar product line that we sell to our distribution side of the company. But as far as training goes, we do live in-person training. So I've got guys out in the field. Our trainers are usually out 2 weeks at a time and then a week at home during the busy season.
Sure.
We also have online classes. Now, right now, we're just doing instructor-led live online classes. We're
Yeah.
kind of going to move to the point where we're going to have some more self-led type training. All of our trainers are NATE, they're IGSPA, lots of other certifications that go with that. So we try to keep up to date as far as our train the trainer goes. And one of the big things that really impresses me about our company is we have a meeting once every 2 weeks with our tech support team, and also including our engineering team as well. So we can take some really valuable feedback from the field and relay that information back to the factory. So
Yeah.
that's a really big thing for us.
It is, and the fact that you're staying that quickly on top of things. Before the show, we were actually talking that you have your team of engineers that are over at Copeland coming
Yes,
back right now, and it's ironically like after the show, I'm headed to Copeland. Literally,
sure.
I'm headed over to Sydney, Ohio after the show, and I'm going to spend the day tomorrow diving into A2L compressors, the engineering that went behind it, and helping us all understand what that transition looked like for the equipment, the amount of changes that were required and what the future of the industry looks like. So yeah, super cool that you guys are jumping back and forth, making sure that products are staying up to date all the time. Hey
Sure.
Murphy, thanks for joining us. Hey, 210 water furnace heat pumps in high school back in the 90s.
Yep.
Exactly. And that's what we're here to talk about. Oh, Tom, hey, that's really cool. I didn't know that. So
Very cool. It's
yeah.
it's kind of neat because I'll be out at a trade show or an IGSPA conference or something, and
Uh-huh.
somebody will walk up and they say, "Hey, I took the class back in like 1984."
Right.
I'm like, "Wow, that's really cool."
Yeah. Right. Well, let's talk about like some of the classes that you offer, and then we'll get into the actual technology and what the A2L transition looks like for your guys.
Certainly, we've got really over 13 classes right now that we offer currently, and we're adding to that as we go. So right now we've got a basic troubleshooting class, which is it's not like a Geo 101 as much as it is how does the technology that you may already know about, how does that relate back to troubleshooting and some installation on geothermal heat pumps.
Right.
We have a residential variable speed certification. In order to sell our variable speed product, you do have to go through a verification certification process. It is a little bit more difficult. There's more controls that you need to know. And we just want to make sure that, obviously, in the end, that our customer's happy with the install.
Yeah,
We have a
absolutely.
basic, oh, I'm sorry.
No, that's right.
Okay. We have a basic product information class that just kind of goes over our equipment. We've got a residential controls class that we're getting ready to break that up into two. So the basic troubleshooting and the advanced residential controls, we try to do everything in a 1 day, 8 hour class,
Mhm.
or for 2 hours online if it's online. And what we're finding is as we go through this, it's really too much to put into an 8 hour class. So we're breaking down the basic troubleshooting and the advanced residential controls into two different classes. We do have our own proprietary zone system. So we have
Mhm.
a class on that. We've got a class that's fairly new. We started it, I believe, last fall, and that's a general installation and basic flushing
Oh,
procedures.
nice.
That's something we've been a little lacking on before, is having a really basic class for those that are going to go out and install the equipment. So that's helpful. I'm going to skip over the airside diagnostics because I want to spend a little time on that. We have an academy class, and we hold that at the factory. So it's a 4-day class, and we go through pretty much everything from the setting a unit all the way up to flush and fill. We have live demos in our training lab.
Very cool.
IGSPA we work with very closely.
hmm
IGSPA is a great organization. If you're involved in geothermal, you really should be a member of IGSPA. And they have their own training classes. Now, the cool thing is our basic troubleshooting and our installation classes are IGSPA certified. So if someone were to take our basic troubleshooting class, they would automatically
Qualify.
they got to go in and take a test.
Yeah, yeah.
But that's the class that they need for that. So that's half of what you need to get what they're coming out with, a new equivalent to accredited installer that they used to have.
hmm
Symphony AWL, we'll talk about that a little bit. That's the connected portion of our equipment. We've got heat fusion classes, and probably the most fun class that we do as trainers is a customizable 1-day training where we'll go to a customer's office with just their people and do a class. And the really cool thing about that for the trainers that are listening, you know what I'm talking about, because if you get a bunch of guys together, guys and girls together that know each other, they tend to ask more questions and be more interactive than it would be if you had a bunch of strangers all in one room. So those are a lot of fun. My trainers love doing it. I love doing it. It just really gets us out there.
Yeah. Well, and it brings up so many of the items that everyone starts seeing in common.
Oh, absolutely. Absolutely. And that's also part of that feedback loop we get back to engineering. If we've got one company that sees a lot of problems with something, then we know we can bring that to them and get that resolved. So the class I wanted to talk about a little bit there in specific was the airside diagnostics.
Okay.
Being geothermal guys, we just really haven't paid much attention to the air side of things for years.
I don't think any of the industry has paid enough attention to the air side. Even the air side people haven't been paying enough attention to the air side.
We put so much emphasis on on the conventional side. We put so much emphasis on the refrigeration part of it, which is obviously good to know.
Yeah.
But a lot of times we forget that everything is a system. So, if we lose something on the air side of things, we lose something on the refrigeration side or vice versa.
Exactly.
And it's the same thing with us on the water side. We really pound water side diagnostics into our technicians. Don't put gauges on these units unless you absolutely have to.
Right.
We can do most of our diagnostics on the water side, but now we're kind of getting back into the air side a little bit. So one of my instructors lives out in Oregon, Carl Robbins. The guy's a ductwork wizard. I'm pretty sure that he's got all of Manual D memorized in his head. He's one of those guys that,
oh yeah,
you see a fitting and he's like, oh yeah, that's fitting, and it's got
I know how much restrictions on that depends on.
Exactly. I think he's got it memorized.
Yeah.
So that's a new class that we just released. We're starting to do a few. I think we've done 2 of them so far. So the other new class that we're working on that's not quite finished yet is a hydronics class.
Oh.
We've had hydronics classes in the past, maybe 10, 15 years ago, but they just haven't been the greatest classes in the world. So we're kind of updating everything and including some of our new equipment that we have out on the hydronics side. And then, of course, with the A2Ls and everything else, there have been a lot of changes.
Exactly. All right. Very cool. All right. The big question, one that everyone gets.
Right.
What is the A2Ls doing to the equipment? How's it affecting? And we spend a lot of time here at ESCO talking about the A2L transition, what the HFC phase down is doing, which is creating this demand for lower GWP refrigerants. And too many times we think inside of a small box, and we see our industry, we see the equipment that we know, but we forget that all industries that work with HFC refrigerants are going through a phase down. Even little inhalers. I don't have mine here right now, but even our inhalers that were using 134A last year are now going to things like 1234. Yep. So, we have a lot of transitions happening in all pieces of equipment. That's why I wanted to have WaterFurnace on here to talk about what is the A2L transition looking like for geothermal?
Well, it's been kind of a big deal for us, to say the least. It's pretty much tied up our engineering department for the last close to 2 years now.
Wow.
WaterFurnace, we kind of were ahead of the game. We started a little bit earlier getting that change made, which is part of the reason we ended up with 454B.
Sure.
And that was because of the GWP numbers. We weren't sure if 32 was going to make that number or not. It does now, so it's okay. But we ended up with 454B, and we switched our entire product line. I think that was complete around October of last year.
Okay.
So we're kind of we tried to get ahead of the game,
Yeah, for
and
sure.
everybody talks about how how much of a hassle it is to make that change, and it was difficult as a manufacturer to do that. On the other hand, we learned a lot from that as well. So we've gotten some really good benefits out of that. For example, most of our mid tier units now, our packaged units have EEVs instead of TXVs.
Yeah,
It's
increases
just much easier to
efficiency.
control.
Yeah, absolutely.
So lots of good things there. I still get, of course, we had to redo all of our training to include A2L, so that
Right.
was kind of fun. And I still get people in class who are like, "Oh my gosh, we're gonna catch the house on
Yeah,
fire. We're gonna blow up a building." Or I'm like, "Guys, it's not that bad.
does
It's
work that
really
way.
not that bad."
I've tried so much, and I did a video a while back of actually doing the flammability of A1, A2,
Yeah.
A2Ls, and the A3s, different ignition sources, and it is so difficult. I've actually had a conversation with my son. He's a firefighter about next time that they do a controlled fire where they're going to burn down a structure. I'm going to try to convince the chief to let me put a complete A2L system in the garage
Oh,
so we can watch it and get
that
an
would be
idea
awesome.
pressurized, and so we'll see. I'm working on that one.
Absolutely. Well, for those that haven't seen your video, I have.
Oh,
As a matter of
cool.
fact, I've played it for some of my classes, and it is an excellent video. It really shows, you know, that it's not nearly as bad as what the internet makes it out to be.
Sadly,
So
it's disappointing. I
it's
tried. I had a whole
yeah, it
audience. I
really
had all the neighbors around. They were just waiting for something to happen, and it was like, poof.
yeah, it just wasn't real exciting.
No, it wasn't.
So it worked out well. But that's the main thing is trying to get people past. You probably don't need all new tools. I know guys don't like to hear that, but you probably don't need all new tools. You probably don't need. There's not that much. And the nice thing is with our systems, most of what we sell is packaged.
Right.
So it's inside the house, which you're like, oh gosh, that must be worse. But it's not because it's a ducted system. So if we have ducted systems and we can use, all the volume of the house that's connected to that ducted system, we really don't run into that many issues. And until you get over pretty much, and it varies, you'd have to check the installation manuals for
Right.
sure. But until you get over like a 4-ton unit with
Yeah.
ours, we're under 62 ounces.
Exactly.
So it really doesn't matter anyway. So
Yeah.
it's just not nearly as big of a deal for the technician in the field as what everybody kind of thought it was going to be.
Yeah. Yeah. And that's where it always ends up right there around 4 pounds for that M1 mitigation strategy. So
Yeah.
that's intriguing because I would think about that. And yeah, because you don't have even though it's a 4-ton system, we're talking about, typical line sets, we're talking about a, system that doesn't have a high charge capacity.
Right.
So a lot of times you're not even going to have a refrigerant detection sensor or mitigation connected to that.
That's correct. As a matter of fact, most of our units
Very cool.
do have mitigation on them, whether it's
Right.
necessary or not.
Okay.
Uh,
Good.
Especially like our inverter technology. We
Yeah.
we make a 2-ton. We call it a 7 series, our variable speed unit.
Yeah.
But that does have mitigation on it, just because it's there.
Mhm.
So
Yeah. Yeah, you already got a control board on that. You've already
yeah,
got an inverter control board. It's at a point, it's just programming and adding a sensor onto it.
absolutely,
Nice.
absolutely.
Okay.
So this is kind of an interesting slide. I did this to kind of raise some questions,
Okay.
and it comes from my personal experience, really. And if you look at the slide, it's got a picture of a geothermal heat pump on one side and a picture of a conventional system on the other. And the statement at the top is when it comes to service, they are exactly the same, but a little bit different.
Hmm.
And I always laugh when people say that they're exactly the same, but they're a little different. Well, then they're not exactly the same.
Right.
Well, they're not exactly the same, but they're extremely similar. And like you mentioned earlier, when we were talking about refrigeration, it all does the same thing. We're moving heat from one place to the other. With an air conditioner, obviously, we're taking heat out of the house and moving it outside, or a heat pump, we're taking heat from the outside and moving it to the inside. We do exactly the same thing. The only difference is instead of having a condenser outside, we've got a loop in the ground. So we're taking heat from the ground through the refrigeration process and putting it back into the house. And in summertime, we're taking heat out of the house and essentially putting it back in the ground. So really, it functions the same, and from my personal experience, and it relates to a rack system. It's funny you brought that up. I had never worked on a rack system. Some young guy out of high school, basic refrigeration knowledge and not much more than that. And my boss sent me out to a job that had a rack system on it. And I walked in and I'm like, oh my gosh, what
Thrown to
is
the
this?
wolves.
Yeah, no kidding. And I looked at it and I thought, man, that thing, there's no way. I don't even know how to start this thing up, let alone troubleshoot it. And I had, luckily, one of the older technicians followed me up, and he walked in and he could see that I was just lost. And he says, he was kind of a gruff old guy. And he says, it's just a refrigeration system. Go fix it. And I'm like, and I thought about that and I got a little angry. And then I thought, wait a minute, it's just a refrigeration system. I know how this works. And once I started breaking it down into its parts and pieces, it really wasn't that difficult. And I think a lot of technicians get that mindset. We see something that we don't recognize, that we're not familiar with, and we just kind of shut down. And we just, don't break it down. So when we start breaking things down, and I do this in class a lot, I'm like, okay, guys, what causes high pressure on an air conditioner? And, people are going, no condenser fan
Right.
or whatever it happens to be, or overcharged or bad switch. And I'm like, yeah, okay. So really, though, in general, what causes high pressure is lack of flow across the condenser.
That's it.
So in our case, if I'm running an air conditioning with my geothermal heat pump, my condenser is my coax heat exchanger. It's, that's where the condensing is happening.
Yeah.
So lack of flow across the condenser, to me, is lack of water flow through the unit in the air conditioning mode. And I'll ask, so what causes low pressure? You go out to an air conditioner, it's got a low pressure situation, and they're like, well, it could be low on charge. I'm like, well, yeah, that could be. Could have a bad low pressure switch. That's possible. Could have some wiring issues. That's possible. But generally speaking, lack or low pressure is caused by lack of flow across the evaporator. So, dirty air filter, dirty air coil, fan motor not working. It's the same thing with our system. If we're running in the air conditioning mode, our evaporator is still the air coil. So it still could be a dirty filter, a dirty coil, blower motor, whatever. So if you really just break it down, and that's the main point I try to get across to people in class. This is not something difficult. You might not have seen it before, but it works the same. So you can't let it block you just because you haven't seen that.
I remember, excuse me, at one point, my mentor he's very much like you. He explained everything in comparison. Right. Let's take something and I'll help you understand something that you don't know by just showing you the differences. And we had our own lease ice machines. So we had a whole bunch of ice machines. And, this was fairly on in my career. And we were talking about geothermal one day, and we were at a job site, and it had a water-cooled condenser ice machine. And we were just talking about the refrigeration cycle. And he was like, okay, what about geothermal? I'm like, okay, I don't understand geothermal. He's like, you understand this ice machine? And what makes this different than one with a fan? And I'm like,
yeah,
not really. He's like, it's just where we put the heat. That's all that it is. It's we're using water out of the ground instead of using temperature from the air.
Exactly.
Like, well, that's interesting. So I love that you're doing that analogy so people can understand that it's not like this magic, appliance that it's another refrigeration circuit.
No, it's just another refrigeration circuit. And it's obviously very, the efficiency is really high because we're using, ground temperature that averages. It's not always, but averages around 50 degrees around the country. So it's kind of like running an air conditioner when it's 50 degrees outside.
Yeah.
Or running a heat pump when it's 50
Heat pump
degrees
is even
outside.
better. Yeah.
Absolutely. So, and of course, the loop temperature does change throughout the year, but generally speaking, it averages about 50 degrees. So that's where the efficiency comes from. It's not magic. There's nothing special about it. So that kind of brings me to another point that we kind of touched on earlier before the show, and it's the same. Excuse me, the same old guy. Now I'm the old guy now, but it was the same old guy that was helping me out. He used to do the touch and feel method. And I teach that in class now. We have a couple slides on it. It's not like we spend a ton of time on it, but he would walk around on the refrigeration circuit and just start feeling it.
Start feeling.
And, he'd feel around a little bit and he'd look at me and he goes, oh, that condenser's plugged. Go clean that, or that evaporator's plugged. Go clean that coil out. And I'm like, gosh, this guy, he's some kind of wizard. I mean, how did, I get up there and the, evaporator coil's dirty. I'm like, how did he know that? And, it's just a simple matter of just kind of feeling around on the system. And obviously we're not going to do specific diagnostics with that, but it's a place to start.
Yeah.
Um, and usually when I talk about that in class, somebody will say, "Oh, beer can cold." I'm like, there's something to beer can cold.
Sure.
We're obviously not going to charge by it. We're not going to diagnose completely by it, but it's a good place to start. It gives us an idea. Anything over 140, you can't leave your hand on typically.
Hmm.
If it's more than 85, it's going to feel warm to the touch. If it's less than 85, it's going to feel cool. And unless you're really good, you can only tell about 5 degrees difference.
Sure.
So we use that a lot in class. We do that when we do our hands-on. And we're like, just feel around on
Tell
the
me
unit,
what you
see what
feel.
it's doing. Absolutely. Don't be afraid to touch it. Don't burn yourself.
Right.
Little
You'll know it
caveat
if you
there.
shouldn't touch
You'll
it.
know it. Yeah, if it's over 140, you'll figure that out.
Right.
And part of that is we don't want people putting gauges on our equipment
I agree.
unless we just absolutely have to. And that should be a rule for all equipment, not
Yep.
just geothermal. But with our systems, they're usually a pretty small refrigerant circuit. So, I take a little 3-ton unit that we have, or even a 4-ton unit, we're looking at 60 to 65 ounces of refrigerant.
Hmm.
So by the time you put because everybody's got 4-foot hoses on their gauge set,
Yep.
by the time you put a hose on, take it off, you can change that a little bit. And along with that, you have, the chances of introducing contaminants into the
Contaminants.
system.
You bet.
So, moisture, other contaminants, non-condensables. So we do want to avoid putting gauges on them at any time we can. And we have a couple methods. Obviously, the touch and feel method is a good place to start, but we also have waterside diagnostics. So just like you would do, like a BTU, like, delta T times CFM times 1.08, we have the same thing on the water side, and it's
Oh, sure.
delta T times GPM
Right.
times the
Pressure
fluid
flow.
factor.
Yep.
So it's the same formula. It's just different, a little bit different numbers. Instead of having airflow, we've got water flow.
Yeah.
So really the same.
Oh, nice. Yeah, it's a great perspective to think about. Yeah, because that's all we're doing is talking about the amount of heat that's being transferred based on velocity.
Absolutely.
Mhm.
It's the same thing. I noticed Patrick's comment up there. Or what country you're in, too.
Yeah, that is true. Yeah, if Todd Klur is with us, he spends a lot of time in Germany, and his beer can cold is not my beer can cold.
Exactly. Exactly. So again, that's kind of the main thing I try to get across to people is geothermal heat pump, whether it's a water to water or a water to air unit, it's really no different than what guys are used to working on every single day.
Right.
So just not much difference. So this is kind of where this all ties together. This is our troubleshooting and startup form. And there's two sides to this page. I know it's going to be kind of hard to read.
That's right. I blew it up. It should be decent to see.
But on the right-hand side, numbers 1 through 5 are just basic information. So the top part of it is, model, serial number, what type of a loop it is. Number 2 is determining what our GPM is through the system. And again, I kind of relate that back is, if you don't know you have flow across your condenser with a geothermal heat pump, that's the same as, if you were to go out to work on an air conditioner and you didn't know if the condenser fan was running.
Exactly.
So we want to make sure we know what our flow is. The next portion of that is the temperature rise and drop across the heat exchanger. So we want to know what our water temperature in and out is on that. And then, of course, our air side as well. We want to know what that air side delta T is doing. Once you get all those numbers, number 5 on there, which again, it's kind of hard to see, but it's right in the middle of the
heat
page
rejection.
on the right-hand side.
Mhm.
It walks you through the formula to do the heat of extraction, heat of rejection analysis that we just talked about.
Yeah.
And again, that's simply delta T on the water side times GPM times the fluid factor. So
fluid factor is really the restriction or the resistance.
But correct. It's
based on the type
an
of fluid.
right. It's a assigned
Mhm.
number that we put to see how much heat that fluid will carry.
Yeah.
So water's 1.0, I'm sorry, air is 1.08, kind of depending on your altitude if you want to get really technical, but 1.08 will get it most of the places. And with water, we use 500 for pure water.
Mhm.
And then we'll use, depending on what you've got, 490 or 485. It doesn't make that much of a difference in your overall numbers for a methanol or propylene glycol type system. So if I know what antifreeze is in the system, or if it has antifreeze, I know what my water flow is through the system, and I know what my water delta T is, I can tell how many BTUs I'm either extracting or rejecting back to the ground. And that's kind of my starting point. Now, the cool thing about that is the number one issue that we have with geothermal heat pumps, and I think anybody that's ever worked on one will agree with me, is lack of water flow.
Okay.
That seems to be our number one problem.
You mean like
So
dirty
as
condenser coils? I mean, like, relatable
well,
here?
usually it's not as much dirty condenser coils as it is
Mhm.
maybe a bad loop pump,
Yeah,
or if it's an open loop system, there's it could be a number of things.
sure.
Surprisingly, we don't run into that many dirty water coils. Even on open loop well water systems, we're taking water out of the well
Right.
and running it through the unit and discharging it. And part of the reason is we want to make sure we've got good water before we did something like
Sure.
that. So we'd have to have water tests and that sort of thing are really important there. So as you're going through this chart, the very first thing after you put the model and serial number in is your water flow. So we ask our technicians before they call tech support, fill this page out 1 through 5. Don't put your gauges on. Just basically, you've got a pocket thermometer to give you water
Yep.
temperatures, and you've got a pressure gauge,
Non-invasive. Yeah.
just the basics.
Mhm.
And most of the time, when you get to number 2, where it's asking you what your water flow is, and you look it up in the book, and you find out it's not good enough,
You go,
gosh,
wait a
God,
minute.
don't need to put my gauges on at this point. I've got a water flow issue. So that's kind of nice. Now, if it does get into the refrigeration side, the left-hand side, and it also continues down. I think it's number 9 at the bottom of the right-hand side page there. But on the front page, which is the left, on that side, it's got the full troubleshooting circuit on there. So the entire circuit's there, whether it's a water to air or a water to water unit. And the nice thing about that is we realize as geothermal trainers that not everybody does geothermal every day.
Sure.
And I'll get people call up and they'll say, "Hey, I'm trying to do subcooling. Where's my liquid line?" I'm like, "Well, where's your liquid line on a conventional system?"
Right.
And they're like, "Well, gosh, I think it's after the condenser." I'm like, "Well, exactly the same. It's after the condenser. Liquid line is always after the condenser because that's where the liquid's at." So we try to make it easy there. So if you're looking at the chart and you don't remember where the condenser is or where the evaporator is, and you don't want to, have to go through the whole process in your head, we've got a cooling cycle analysis and a heating cycle analysis that shows you exactly where all those temperature points are to be taken. So it just makes it really simple. Most of the time, if somebody fills this page out and they've gotten past the water flow and everything's good there, and they've gotten into the refrigeration side, if they can't figure it out by the time they start putting the numbers down on this sheet, more than likely they're going to figure out the problem on their own.
Yeah.
If they can't, if somebody can hand me this picture with
Yeah.
all the numbers filled
Give me your
out,
data.
yeah, absolutely. And when you look at this thing, it's, there's very little you can't figure out from looking at this page. So it makes it kind of nice. Little story if you've got time for it. I have
Oh, yeah, absolutely.
the company I used to work for on the contracting side. I ran their service department and I did their retrofit sales side of things. It was a big company. We did probably, gosh, I don't know, over 100 new homes a year and probably 85 to 90 existing homes.
Sure.
So, and I had full-time service guys, 3 full-time service guys that did geothermal every single day.
Wow.
So we didn't do anything but geothermal. That's all we did. So we had some really good service guys. These techs, the least amount of time that I had, there was a guy that had like 3 years of doing strictly geothermal every single day. The other guys I had were 10 years plus. So, and that's all they did was geo. So I get a call from one of my technicians, Gary, if Gary's listening.
Hey, Gary.
Gary calls me up and he says, "Hey, I got a problem. I've got a situation where I think I've got a bad TXV," because obviously it's always the TXV.
Sure.
So I said, "Really, Gary, a TXV?" And he's like, "Yeah." He said, "It was a brand new unit. It had been installed for like 2 weeks." I'm like, "Gosh, that sounds kind of strange." He says, "Yeah, it's even worse." He said, "Our other service guy just left there like 2 days ago and had replaced the TXV." And I'm like, "Well, then I don't think we have a bad TXV here, Gary."
Right.
And he said, but I got thinking, okay, so maybe he overheated it, putting it in. Maybe there
Right.
were issues on the install, whatever. I said, well, before we do that, and I had one of these sheets sitting right by my phone.
Mhm.
I'm like, "Gary, let's go through this real quick." So we started going through it, and I asked him, what's your entering and leaving water temperatures, pressures? We did the heat of extraction, heat of rejection. It was way off. So I started asking the refrigeration stuff. I'm like, "All right, what's your suction pressure? What's your suction temperature? What's your head pressure? What's your, going through the whole thing."
Yeah.
And it was off. And I said, "Okay, well, let's keep going." I'm like, what's your supply air? And he gave it to me. I said, what's your return air? And he says, hang on a second. And I kind of heard him put his phone down. And I could hear some rustling around in the background. And I hear him pick up his phone and he goes, oh, fudge. And I'm being
The
nice.
number that wasn't
He didn't
inputted.
really say fudge, but it was fudge. And I said, what? And he says, well, gosh, I was moving my probe over to get the return air.
Yeah.
And I pulled the filter and it was plugged.
Yep.
And I'm like, and I don't tell that story to make Gary sound bad.
No, it's common.
I tell that story because we all make mistakes.
Absolutely.
And it's so easy when it's really busy, middle of the summer. For example, we're out there working hard. It's 8:00 at night. Your significant other is texting you, wanting to know why you're not home yet, and you're going through the process and you just miss something. So that's what this form does. It makes you go through the basics. And too many times, and I know in my personal experience, when I look back on the units that really stumped me, it was always something simple.
Yeah.
Always something simple that I had overlooked. So that's one of the things that this does. It keeps you in track and it makes you go through the whole thing. Now, the cool thing is, now that we're talking about this sheet and how cool it is, we have software that does that for us now.
Okay.
So we'll get into that here in a little bit too.
Yeah. Because when we start looking at that, that's all inputs, right?
Yes.
And so if I have inputs and I've got a good formula, my output is, what is my problem?
Exactly.
And as an industry, we're starting to transition to that. And that's really caught my curiosity when you and I were going through this presentation beforehand. I'm like, we could probably spend half of the show just talking about that side of the industry and how it's really helping everyone.
Oh, absolutely. We're seeing advances every day on this. And again, I'll show you later on when we get through it. When we get to it, we have some tools out there that make this so much easier.
Nice.
So one of the tools that we have, we call it our Symphony system. The Symphony system is an online platform, and we use something called an AWL, which is Aurora Web Link. The Aurora Web Link is the small box that you see on there, and it's basically a router. It plugs into the geothermal heat pump, and it allows it to communicate to and from our servers, so we can have a connected system. So it does some really cool things for us. That's what it kind of looks like on the inside. The box itself is, there, and then it's got the router on the inside of it. For the homeowner, the neat thing is it gives them complete connectivity to their equipment. So, it's through it's symphonyonline.com to get into that. And they can go in and adjust their thermostats remotely, adjust their zone system remotely. But the cool thing is, it's even probably better than that, is it gives notifications. So if there's a problem with the system, it gives a notification that the system is faulted out or locked out. And the cool thing about that is it's not just that the system's down, but it tells them why it's down.
Right.
So it tells them what the fault is. Now, for our dealers and our technicians, it's even better because we can monitor all the equipment that's on our systems. So if I have 20 customers out there, I can see what each of those units are doing all the time. And I'll give you a little bit more details as we get into it.
Okay.
And also notifications. So, it might be maybe it's a Sunday night, you get a text message at home that, Mr. Smith's unit just locked out. So you can, if it's a major lockout and he doesn't have any heat, for example, in the wintertime, I can give Mr. Smith or Mr. Jones a call and say, hey, do you want us to send somebody out? We've got a problem with your system. So that makes it nice. But even better than that for the dealer and the technician is I can diagnose a unit online without going to the job site. So, for example, if I had, we were talking about earlier, if I was at the middle of the summer and I've got a low pressure fault with the unit, I can call the customer on the phone and, especially if it's Sunday night, and say, hey, have you changed your filter race recently? And on top of that,
let me save you a service call, please.
Oh, yeah, absolutely. Well, on top of that, not only can I ask that question, but I can see what their coil temperature is.
Right. I
can see what their fan amp draw is. So, all that kind of stuff I can look at. And the cool thing about that is, I don't have to send a service tech out to the job without the parts that he needs. So there's so many benefits to that I think as a company, we don't push this hard enough. We should push it a lot harder because it really does save a lot of time in the field. And as a technician, it just makes your life a lot easier. You know what parts to have. You know what to expect when you get there.
I
So
think
that,
we're going to have to migrate to this fairly quickly when we start looking at the shortage of technicians across the board and
oh
the
yeah,
amount of experienced technicians that are going to be retiring over the next 5 years. 40% of the workforce will be gone in 5 years. Right? We have to get to the point where we can be smarter about our service time. Right?
sure.
Service technicians are the higher paid, typically the higher paid jobs. We don't have as many of the service technicians as we really need, and so we need to make sure that we're utilizing those calls, appropriately, and that we're getting things done as fast as possible. And remote diagnostics is going to be absolutely critical for that.
Oh, it sure is. Absolutely. Well, this is what I'm bringing up here. It's a little slow starting up for us,
Sure.
but this is our Symphony system. Now, I'm logged in as a water furnace tech support person right now.
Right.
So currently, I'm seeing 18,210 units that are online
Really?
across the country, and that's the ones that are online. We've got 6,000 offline right now, and that could
Right.
be because they've, I don't know, maybe they've changed internet
Right.
providers or
Service, different
whatever
homeowner,
happens to be.
whatever. Yeah.
Yep. And we do contact those people to let them know. But there's 18,210 units online right now. So if you were a dealer, you would have this list of all of your customers. I mean,
Sure.
obviously, you're not going to get everybody else's customers. So I'm going to pull up our training lab unit right now, excuse me, so we can kind of take a look and see what this thing will do for us. So this is our training lab, and I'm going to go into the little wrench here. Now, this screen is very similar to what a homeowner would see. So they would
Okay.
have, their thermostat summary. In this case, I've got two zones. I've got a living room and a kitchen. Right now, this system is running cooling stage 2. On the equipment summary, I can see what my compressor speed is, what my blower speed is. I can see my loop temperatures, my return and supply air. On the right side, I can see my current energy usage in
That's
watts.
measuring wattage?
That's measuring
Really?
wattage. Yeah, and it's doing it. The cool thing is we're not just guessing. These are current transducers
Oh
on
my goodness.
so current transducers on the fan, on the electric heat,
Yeah.
on everything is being measured there. So my total unit energy on this unit right now, running speed, what we're running 9, which is one speed off of high speed cooling.
Hmm.
It's running 1200, and I know it's kind of hard to see there, but it's running
Yeah. 1272.
1272 watts.
Uh-huh.
So I mean, you think about it, that's my wife's hair dryer is
Yeah.
1500 watts.
Exactly. Yeah, because
So
our compressor is running at, close to peak speed.
absolutely.
Not quite there yet, but I mean, it's up there.
No. Yeah, it's got one more speed to go in cooling. We
Oh,
run 10 in cooling and 12 in heating. But that's, 1049 watts is what the compressor is doing. My total right now is 1284. So it's
what
it's
size
just
unit is
amazing.
that, out of curiosity? Is that a 3-ton that I see in the
It
model?
is it is. That's a 3-ton.
Really?
Yep. Yep, absolutely. It's not uncommon. I show people this a lot in my house. I have a 5-ton unit in my house. And I'll show people, in the middle of the winter when it's like 10 degrees outside. I'm like, look, I'm heating my house for the same price it costs to run a hair dryer.
Yeah.
It's just unreal.
Wow.
So this is the main screen. Again, the homeowner would be able to see this. They've also got a dashboard screen. Um, well, that is the dashboard screen. I'm sorry. They've got a thermostat screen, so they can do all their adjustments on their thermostats. They can get into pretty much anything they want there as far as thermostat controls. They also have an energy chart in here as well. Now, this is a lab unit, so it's probably not a good
Right. It's not on
example.
all the time, but yeah.
Right, right. But it does show you what this is in kilowatts right now. So it looks like in August we've used 67.96 kilowatts, but I can change that to dollar and cents and put my kilowatt cost in there. So the
Yeah.
homeowner is able to get to this screen. So the nice thing about this, and I wish I would have had it, 10, 15 years ago when I was doing service in the field, because you get a call from a homeowner like, oh my gosh, my electric heat's on.
Yeah.
What am I going to do? It's costing me a fortune to run this thing. And had I had this, I could say, well, pull this up online and take a look at it. And you can see that, gosh, all year you used like $3.50 worth of electric heat. Yeah, maybe you're not using
Wow.
as much as you think you are. And again, this is measured data. It's not
Yeah.
projected what we're doing. That's actually current transducers on the equipment.
Yeah,
So
that's
that's
why I was fascinated when I seen that wattage because I've been working as a on a subgroup for I'll just say a federal energy agency and some utilities on what a connected commissioning system would look like that could be used for commissioning and monitoring HVAC systems, so that you can actually watch like wattage, energy
Oh
usage.
yeah,
And this is like the perfect example of why we want that integrated into our home network. Um,
certainly. Well,
it's
I don't want to go
fascinating.
down a whole nother rabbit hole, but there's this thing called TENS out there, TENS,
Okay.
and that's thermal energy network systems.
Oh yeah.
So what's happening is, and we're actually working on one right now on the East Coast. I've been working really close with a company that used to be, still is kind of, a gas company. So
Hmm.
they're doing, gas lines. So the cool thing is, if they can do gas lines, they can do geothermal loops.
Oh,
So that's kind of nice. So a lot of their employees, because their new installation of gas lines is kind of fading away a little bit,
right.
we're kind of transitioning them over to doing geothermal heat pump loops. So
Man.
what's happening is the utility company is going into a subdivision and doing a loop for the entire subdivision, and then they'll put individual units on that loop just like you would a gas line.
Oh,
So
that's fascinating.
it is just amazing. It's kind of in its infancy right now. It's been done a couple places. We've got some experience in it, but that seems to be growing really fast. Um, some issues we had with the tax credits. We don't have the
Right.
residential anymore, but they will allow a company to lease the loop out, and that company that's leasing the loop can get the tax credits on the commercial side.
On the commercial.
Yeah,
Yeah.
so
So your
it's kind of
utility
neat.
provider, it's perfect for them, especially those
Well,
ones that are struggling, some of those areas that are not they're banning new gas connections. Well,
right.
now they have an additional resource and income. So we can start
Yeah.
balancing this electrification load.
Absolutely, absolutely, and every utility I
Me
talk to a lot of
too.
utility companies around the
Yeah.
country. Every one of them is worried about, having enough infrastructure to
Oh yeah.
supply the power
Hmm.
because the demand is already over the supply.
Yeah.
So, there was a company I was talking to up in, Minnesota that was firing up diesel-driven generators
Yeah.
to level out their peak,
I've heard that.
and they're like, "Gosh, is there something we can do?" And I'm like, "Yeah, we can put
Yeah.
geothermal in people's homes,"
Yeah.
and that solves that issue. But anyway, that again, I can go down a whole rabbit hole on 10 systems, but it's kind of neat how that's happening. And it's, people that may be out of work because they're not putting gas lines in, equipment that's setting idle.
Yeah.
We can put the guys back to work and get that equipment running again on the geo side.
Yeah. Get those directional borers going to
Oh yeah,
work.
absolutely, absolutely. So back to what I was talking about here.
Yeah.
This would be something that the homeowner can see. Now, the homeowner
Yeah.
wouldn't have the top line up here where it says aid tool, T-stat config. Obviously, the homeowner couldn't get into that sort of thing.
Sure.
But as a technician, anywhere in the world, I can click on aid tool, and that's our diagnostic tool that typically is a handheld tool
Hmm.
that you would take out to the job site. I can access everything I could access at the job site. Now I can do that remotely. So
Ooh. Oh,
it's
so
really,
you have
really
a
neat.
new startup that's not connected to the internet yet, and we want to do a commissioning of that system and get a
Oh yeah.
baseline report off from it.
Yep. I can do an entire commissioning on the system remotely. The only thing that I can't do remotely is set dip switches.
Yeah,
So,
exactly.
assuming my installer did a good job
Right.
and
Fan
set up the
fan
unit
set up
properly.
properly, load
Right,
set up
right.
properly.
So, this is kind of an overview screen so I can see what the unit's doing right now. So it tells me, what blower it's on, what setting it is, just basic information on it. Below that, though, I have system faults. So if the system was faulting right now, which it's not, it would tell me what that fault is and what mode it's in. I can also go into fault history and see what that unit has faulted out on in the past. So we use a fault retry system with our
Yeah,
equipment. So if it's something like a low pressure, for
yeah.
example,
Soft
it,
retry.
it may just be an anomaly.
Yep.
So we have like a 3-time fault. So once it hits that third time, then it'll lock the unit down.
Mhm.
So if I'm doing a diagnosis on the unit, I can come down here through here and just see what it is. This unit, for example, has had 3 critical communication faults. So that tells me that it's had issues talking to the thermostat.
Mhm.
Now, this unit because it's in our lab, our engineers like to take advantage of that
Hmm.
and use it to test things out. So they probably
Yeah.
had the thermostat unhooked at one point.
Yeah.
So it's kind of hard to use this one for an exact example.
No,
But
it's cool though. I mean, those are the things that I preach for the rest of the industry is that, many parts of our industry are behind with technology. This is the reason we are integrating thermistors and transducers into the air
certainly,
side because we're doing such a good job on the water side. I didn't realize how advanced this was
yeah,
already.
it's just amazing what this will do. This is
Yeah.
the diagnostic screen. For example, here I can go into manual operation, and this is an inverter technology equipment here. It's a variable speed.
Yeah.
And I can tell it, well, gosh, let's put it in cooling. Let's run the compressor at speed 10. We'll allow the blower and the pumps, the loop pumps,
Yeah.
to run with it. And then when I click save, as soon as I hit that button, that unit's now running speed 10. So remotely. The cool thing about it is I showed you the troubleshooting chart earlier.
Yeah.
Now I can come up here to the troubleshooting.
And I got inputs.
There's my troubleshooting chart
Oh, are you kidding me? Look at
already filled
that.
out. Already filled out and ready to go. I've got discharge temperatures. It figures my saturation temperature, so my discharge temperature, my discharge pressure, suction pressure, and temperature. There's my superheat and subcooling, which are strange on an inverter if you're not used to that.
Right.
There's my cooling liquid line, my heating liquid line, my air delta T, entering air humidity. Everything is there.
Yeah, true enthalpy. Mhm.
Absolutely. Left-hand side over here gives me my thermostat inputs and outputs on the system. On the right-hand side, I've got my water parameters. So it tells me what my water flow is, what my delta T is. Electricals over on the right-hand side. So again, if I was trying to diagnose a unit, let's say it faulted out or locked out in low pressure, middle of the summertime, I can go in here and see, well, gosh, does my fan have any amps? If my fan doesn't have any amps and I've got a call coming out of the board for G and my fan's not, well, gosh, maybe I should put a fan motor on the guy's truck before I send him out there.
Yeah.
So I can see all that. So everything's right. Now this unit's a little different. It looks a little more complicated. This is what we call our OptiDry unit. So this is a hot gas reheat
Yeah, I
unit.
see that.
So yeah, it's a
Bypass valve.
modulating hot gas. So
Uh-huh.
that reheat valve is in
That
there. So
secondary coil.
yeah, so maybe not the best choice to show everybody today, but it's
Oh, it is for
pretty
me
neat unit.
because it lets us see that we've got that capability as well.
Absolutely, absolutely, and we can see what the entire system's doing. And if the cool thing is, again, if you don't do geothermal every day and you kind of forget, well, gosh, which way's my refrigerant going? We've got arrows on here showing you where everything's going.
Here's the cold
So
line. Go touch it.
absolutely, I mean, there's my cooling liquid line, 76.8. Well, gosh, I should be
Man.
able to tell what that is with my hand, or at least get close. So there's some fun things we can do there. I'm going to back up here again.
And these are residential units.
Absolutely. This is all residential. I'm going to disable the
That's
operation
insane.
on this.
Okay.
And then we're going to go back in and just take a look real quick. In the diagnostics, if I want to see it kind of broken down, I can go down here to sensors and refrigerant,
Yeah.
and I
look
can
at
see
them
what all my
individually.
pressures and temperatures are.
Ah,
So this chart will show me, there's my EEV superheat, and I just shut the unit down, so it's
yeah,
changing
exactly.
now. But and there's my my percent open on my EEV is there. I've got my subcooling, my compressor ambient temperatures. Everything that I need is right there. There's really, when you have this amount of technology on the unit, I I really don't even need my gauge set.
No.
I can do this. Now, we also have an app for your phone that I'll show you here in a second. But this is just an online, anywhere in the world, I can pull the unit up. Oftentimes for, um, gosh, I got a message up there. Something went wrong. Are we okay?
Yeah.
Okay.
Now is this
Um,
only from the supervisory mode, or do service technicians have access to some of this data?
it's totally up to the company and what they want to do. So within our system, we allow each individual contracting company to assign a username and password to a
Priority level.
technician.
Yeah.
Right. Right. So they can see, most everybody will give them at least access to this so they can see what's going on with the system.
Man. Oh,
And
man.
this is strictly, well, anymore, it's more for a remote diagnosis than
Yeah.
anything else. So there's all kinds of things here, though. We've got performance monitoring. We can see, we talked about heat of rejection, heat of extraction. Right now, this unit, again, I think it's kind of shutting down.
Yeah.
No, it's running 11.2 GPM. It's running 6,200 BTUs, which is kind of,
Yeah. It's
but
ramped
we
down.
can, all the neat formulas that I showed you on that
Yeah.
written page,
Yeah.
it's all
They're all
done for you
calculated.
right here. It's there. So that makes it kind of fun. On top of that, just to give you an idea, the sensors, we can go in and see what they are. If you've dealt much with geothermal heat pumps, another problem that used to be a big problem in the past was freeze thermistors.
Yes.
And the way we used to diagnose a freeze thermistor is we'd go in, typically you'd cut the wires, wire nut them back together so it'd see 0 ohms.
Yep.
Get out your ohms meter, measure your ohms going down to the thermistor with the unit running. Find this huge chart somewhere in the installation manual if you're lucky enough to have it with you. Look at your ohms, see what your temperature is supposed to be. Get out your temperature probe, clamp it on the line, and see how it matches up.
Verify it. Mm-hmm.
Much easier. Here's my heating liquid line temperature. Right now it's 47.4. That's what my board's reading. So all I got to do is get my temperature probe out, clamp my temperature probe on, see what it reads, see what my board is reading, and that's it. I don't need to get that ohms chart out. Now, if it were off, I would probably want to verify it.
Absolutely.
But
But
at
first
least,
glance readings, I mean,
oh, absolutely. Just amazing what that'll
wow.
do. So there's my pressures, there's my suction pressure, superheat, subcooling. It's all right there in front of me. And I'm just scratching the surface on this part of it. So it would take me a good hour to go through all that. Now, the other thing that this does is I also have historical data. So I'm going to click on the historical data tab here. It does take it a second to load. So there we go. I'm going to reset all my column widths. I was playing around with it earlier. So on the left-hand side, again, I know this is really tiny letters and it's really hard to see.
Right.
But the left-hand side is the date and the time. What you can't see here really is this is taking, basically it's taking measurements every 10 seconds.
Yeah.
Correct. And it's over 90, I think there's 97 different points that it's taking every 10 seconds, 24/7, 365 on this unit. So I've got my water and air analysis in the blue. There's all of my refrigeration parameters in the green. There's my control inputs, my control outputs, my energy monitoring, so I can read all of my amps and watts through there. And the right-hand side is drive details. The neat thing about this is if, let's say, a customer called in and they said, hey, my unit locked out the other night, I reset it, everything's fine now, but I don't know what happened. All I have to do is go here to faults and it'll pull up whatever my last fault was. Like here you see lockout. And this was that E19 critical communication error. If I click on that, it'll take it a second, but it'll load back up here. Whoops, maybe not.
Right. Okay, what kid ran down the hallway and knocked the thermostat off?
Something happened there. But it'll actually take me to the date and time that happened.
Sure, absolutely.
So once it does that, I can go back over to the troubleshooting chart that we just had up and see what it was doing when that fault occurred.
At that time.
And I can advance it or bring it back 10 seconds at a time. I can go into bar graphs with whatever information I want. I can make it just show suction pressure only, for example, or maybe just delta T on the air side or water side. I can see that in a chart. I can see it in a bar graph, or I can actually see it on the troubleshooting chart itself. So it makes it kind of nice to kind of see what's going on there. So all kinds of stuff we can do on that side. There's an alert section here as well. These are homeowner set alerts, not dealer set alerts.
Absolutely.
So the homeowner would get a notification, but the dealer wouldn't if something happened. But again, anytime something happens to the unit, if it faults out or locks out, not only does the customer get an email or a text, depending on how they have it set up, but the dealer does too. I have one dealer out in, I believe, Missouri, and they had a service manager who was retiring, and he kind of wanted to retire, but he didn't really want to retire. So they basically pay him to sit in front of his computer
right here
and monitor faults.
What a gig. That'd be fascinating.
Oh, it's just amazing. But not only is it help out because, he can basically troubleshoot the unit before the technician gets there. But like you mentioned earlier, we're getting a lot of young people that don't have the experience. And it's hard to find people. Everybody knows that. And we get somebody in that just may not know enough about Geo, or they may be intimidated by Geo. That service manager on the phone can see exactly what that technician's seeing. And I can't tell you how many times I've used that when I get a tech support call.
Oh
A
man.
technician will call in and you say, "Hey, I've I've only seen geothermal a few times.
Right.
It's doing this, and I don't know what to do." If that system has the AWL, I can log into it with him, and I can see exactly what he's seeing
Live.
on the screen. So it's just a wonderful thing. And there's
Man.
the other neat thing about this is we don't charge for this system. Uh,
What?
I mean, you pay for the box
Yeah.
that goes on the unit, but everything
Like
else
the
is
service?
there's no monthly fee or anything else involved in that.
Yeah.
So it's just
Man, oh
amazing.
man, oh man.
Now,
Someday everyone will think this way.
absolutely. Now there are some we do use some of that data, or we plan on using some of
Yeah.
that data. And I'm not talking about customer data. I'm talking about data that
Well, the
we have
diagnostic data. Yeah.
for diagnostic data, right?
Absolutely.
One of the things we can see is loop temperatures.
Yep.
So if we can go back through in different areas and we can, I mean, there's a lot of, it's way over my head on the software side, but there are software engineers that we have that can go in and narrow down. So we can do some double checking. So is our loop sizing software doing what it should be doing?
Mhm.
Are we putting loops in that are too big? Are we putting loops in that are too small? There's lots of different things there. The other thing that's really neat about this, let's see if I can get my screen to share here. Here we go. This is all the units that are connected around the country right now. Now, obviously, we've got more units than what's shown here in dots, but you and I think, are in Indiana. So I'm going to pull up just Indiana. This
Wow.
is a nice little sales tool. My house is somewhere up in this area,
Mhm.
and I can click on that one, for example. This is a 7 Series 4-ton, so it's not my house. It's
Right.
close. But total annual electricity use on this house, 169 or $14 a month. That's a really low one. That may be just like a secondary unit. So let's pick
Right.
one that's a little more reasonable here. Um, this makes a lot of sense. This is 7 Series, so it's variable speed, 4-ton
Yep.
unit.
1-ton unit.
$648 a year, or about $54 a month. And that's very realistic. That's about what my
Absolutely it
house is
is.
costing me. But I can do this in any state. So if somebody says, "Hey, geothermal doesn't work when you get into, Minnesota
Right.
or Alaska even," and I can say, "Well, yeah, it actually works really well." As a
Where
matter of
where
fact,
exactly are you? And I'll tell you.
yeah, I can find right in your county at least. Now these
Yeah.
are randomized, so we
Oh,
can't
yeah.
see exactly where somebody's house is. Uh,
Exactly.
but it's just kind of a neat little feature there. Now, the other thing that we do, since we have Symphony, we also have a handheld tool that'll do the same thing out in the
Oh,
field. And it's got even more features on it. So with the handheld tool, the way this thing's set up is you take it out to the job site with you, and it connects with Wi-Fi to your cell phone.
sure.
So on your phone, you have all the features of Symphony that I just showed you, plus troubleshooting on top of that. So it's not just giving you the data. And I know we're getting a little short on time, so I'll just kind of run through something real
Oh,
quick
that's all
here.
right. This is really good stuff.
Oh, I could talk about this for hours and hours. So I'm going to skip some of these things. One of the things I do want to show you here, though, is a startup checklist.
Okay.
Commissioning a unit can
Yeah,
sometimes be really daunting,
absolutely.
especially to install technicians that may not have the technical abilities. A couple things in this app. Now, you would see this on your phone. In this app, there are videos that you can play to show you how to do things. I can start, let's say, for instance, we can do a startup checklist, and I'll call it Smith, start new checklist. So before starting units, the first one, we can go through here and just start checking things off. Like, for instance, we mentioned dip switches
Yeah,
earlier.
right.
Are the dip switches set correctly? Well, I'm going to check that off, but wait a minute, I'm not real sure. Gosh, those installers took the manual with them.
Mhm.
The little info button over here on the right-hand side, there's all my dip switch settings right there on my phone. Just all kinds of little things there. So startup checklist work really well. On the diagnostic sides, we've got functional troubleshooting. For example, I mentioned an E19 fault earlier.
Oops.
Well, the last locket on this unit was an E19. So if I click on that, it tells me what it is and how to troubleshoot it. If I see another error that I don't know, for example, low pressure, if I click on low pressure, that's an E3 fault. It tells me what it is, troubleshooting and heating, troubleshooting and cooling, or it could be a loss of charge situation. So it just tells me how to do it. Even better than that, on the diagnostic side, if we go into functional troubleshooting, I can go into the controls and do my troubleshooting. So something really easy. Let's say no power to controls. This will ask you questions and guide you
Yeah,
through
walk you
troubleshooting.
through.
So, for example, we're diagnosing a control board here. Is there 24 volts between R and C? Let's say there is. Is the fuse blown? Let's say it's not. Well, gosh, if I don't have any power in my control board, I've got power to it. My fuse isn't blown. Replace the ABC board. So again, I'm just scratching the surface on this. I know we're kind of tight for time, but all your component troubleshooting is in here. We can go through the compressor. We can, read it if you want to, or we can go into verifying compressor signals with the controls. So now it's asking
You'll
you
actually give
questions, but it
commands.
already knows the answers.
Right.
So anyway, really fun stuff.
No, that's fascinating. I'm sure there's going to be technicians watching this video going, I want to be a geothermal technician now.
We've just made it easy.
Yeah.
It was easy to begin with, and we made it easier.
Yeah. No joke. All right. So, Jay, tell us how we can connect with WaterFurnace, because I'm sure there's going to be people wanting to know more. There's going to be educators wanting to learn about the classes to get more familiar with the products and the actual, systems that are available. We'll have, contractors, technicians that'll want to learn more about this technology, I'm sure.
Sure, absolutely. The best way to get us is through our website. Lots of information there, and that's just simply waterfurnace.com. So that makes it easy. If anyone has any specific questions or wants to know more about the product in general, and I'm not a sales guy, I'm the training manager. But if you do want to get a hold of me, it's really simple to get me. It's simply J Hammond, and it's JAY.Hammond@waterfurnace.com.
Okay, everybody. Cool. That's a lot of great stuff, my friend.
Thanks.
I'm glad you joined us
fun.
today.
It's 35 years of being in geothermal, and I'm still enthused about it every day that I go to work. It's just great.
I had no idea that it was this advanced. I mean, there's so much has changed from the geothermals that I seen 10 years ago. This is all incredibly fascinating. Does anyone out there have any questions before we hop off here? There's still quite a few people hanging in. All right. Well, I think I'm going to go ahead and wrap things up. I'm going to be getting on the road and headed over towards Ohio so we can do some behind-the-scenes video shooting over at Copeland tomorrow, which we'll be sharing with everybody here in the near future. Jay and WaterFurnace, we are sure grateful that you joined us. And any other time you want to dive into some technical components of geothermals, I'm sure we'll have an excited audience.
Sounds great.
All right, everybody. Have a fantastic evening, and we'll see you all again next week on Did You Know, the ESCO HVAC show.
Thanks.
Bye, everybody.